This one is about number of molecules in a substance, and it's linking number of molecules to the number of moles that we have. So there's a couple of different ways you could approach this. You could approach this using the atomic mass unit. So you've got carbon 12 and oxygen 16, and you can look at carbon dioxide and say that there are 12 atomic mass units due to the carbon, and there are 32 due to the 2 oxygen molecules. And then you could work that out in terms of the mass of 1 carbon dioxide molecule, and then divide that by 2.2. That's the least chemistry way of doing it. There's a more chemistry way of doing it that I think is arguably better in terms of your understanding of this topic, if we're treating this as a thermal physics and gas laws topic. But I'll show you how to do both methods as quickly as I can, and hopefully they will make sense. So carbon dioxide is 12 nucleons due to the carbon and 32 nucleons due to the 2 oxygens. And each nucleon has about the same mass because the proton and the neutron are about the same mass. The level of precision of the values that we're given to choose from, they are quite far apart from each other. So we might not get the exact correct number, but it's going to be close enough for us to be able to choose. So 12 lots of carbon plus 12 due to the carbon, and then 2 times 16 for the oxygen gives us 44 atomic mass units for the carbon dioxide molecule. And that actually is it's 44 grams per mole as well. So 44 multiplied by the atomic mass unit that we're given in the data sheet is 1.66 times 10 to the negative 27. So that will give us the mass of 1 carbon dioxide molecule. So 44 times 1.66 times 10 to the negative 27 gives us the mass of 1, which is 7.3 times 10 to the negative 26 kilograms. We're then asked how many of those are in 2.2 kilograms of gas. That's a division. So 2.2 divided by that value should give us the answer. So 2.2 kilograms divided by 7.3 times 10 to the negative 26 gives us 3.0 times 10 to the 25 molecules. And that should be the correct value. The other way of doing it, actually, if you look at it mathematically, you end up doing pretty much the same thing, because we should end up with the same answers. So we can use this step again, and we get 44 grams per mole, and then we can work out how many moles there are. So 44 grams per mole, 44 grams is 44 times 10 to the negative 3 kilograms per mole. So 2.2 divided by 44 times 10 to the negative 3 gives us, let's move that down a little bit, it gives us 0. So 2.2 divided by 44 times 10 to the negative 3, we get 0. Wrong way around. Oh, I missed out. Let's sorry about that. Just me checking that doesn't make sense. Divided by divided by 44 times 10 to the negative 3 gives me 50. Yeah, 50 moles. So 50 moles. 1 mole contains an Avogadro's number worth. So the number of molecules is the number of moles multiplied by Avogadro's constant. So we have 50 multiplied by Avogadro's constant that you're given, which is 6.02 times 10 to the 23. And then we get 3.0 times 10 to the 25. Again, we get the same answer. So I think this method feels to me a little bit more likely if you're studying chemistry as well. Both methods are perfectly valid, and they both give the same answer.